Continuing lesson 8.4 on volume of spheres, page 439, try it. They're asking what's the volume of the composite figure shown, use 3.14 for pi. So this figure, similar idea to what we looked at in example 3, only this one we've got a cone base instead of a cylinder base part. So we've got two different parts here. We've got the hemisphere, or the half sphere if you want to call it, and then the bottom part you've got a cone. So start out with, write your formulas for these would probably be a good idea. For a sphere, it's 4/3 pi r cubed. Since it's a hemisphere, since it's a half of a sphere, we're going to take half of that. So I'll just put a half in front of that formula, and that'll take care of the fact that it's just half of a sphere. For the cone, our volume formula was 1/3 pi r squared height. One other option, instead of putting the half, you could put divided by 2 at the end, or you could just figure out the volume as if it was a regular sphere and then take half of it at the end. Just make sure you don't forget to do that. So one thing on this hemisphere, if we do the half in front like this, one option we have actually is to go ahead and multiply those fractions together. And if you multiply those together, that's 4/6. And then if you wanted, you could reduce that to 2/3. If you don't reduce it, that's not a big deal, but you do have that option. So pi, they told us, is 3.14. And actually, I am going to save my pi here because both parts of this have pi in them, like the example 3 in your book. It'll just make it to where you don't have to deal with as many decimals and stuff until at the end. Radius of our hemisphere is 2. And remember, we are going to have to cube that. So we need 2 cubed there. We can simplify this a little bit here. So 2 cubed means 2 times 2 times 2, which is 8. And then at that point, if you want to, you can put that as 8/1. You can multiply across. And then what I'm going to do, saving my pi, I'll just put the pi after whatever number I get here. So this would be 16/3. So 16/3 pi is the volume of the hemisphere. And I know you might think that just doesn't even look good at all. Well, 16/3 is going to be a repeating decimal if you divide it out and then take that times 3.14. You're going to have a whole calculator full of decimals if you mess with that otherwise. So we're just going to leave that for right now as it is. And then let's look at our cone part. So on the cone, so radius of the cone is 2 and the height is 6. And then we can try to simplify this a little bit. So 2 squared, 2 times 2 is 4. At that point, if you want to go ahead and take 4 times 6, another option, if you want to go ahead and just put those over 1 and just go ahead and get whatever number you have in front of pi here. 4 times 6 is 24, and 3 times 1 times 1 is 3. That actually comes out nicely. So that would be 8 pi. So we've got 8 pi for the cone. We had 16/3 pi for the hemisphere or the half sphere. And then at that point we can add those together. Technically, if we were going to do this like we did on example 3, we could put that 8 pi over 1. We can try and get a common denominator first and then add those together. So common denominator of 3, we can multiply numerator and denominator of our second fraction both by 3. So we'd have 16/3 pi plus 24/3 pi. At that point, since our denominators are the same and they both have pi's next to each other, these are kind of like terms, kind of like if we had 16/3 x and 24/3 x, that we were allowed to combine those. So that would be 40/3 pi. And then at this point, we could put in the 3.14 for pi. You know, if you want to, if you have a calculator you're allowed to use, you can do 40 divided by 3 and then just put times 3.14. Otherwise, you can put 40 divided by 3 in parentheses and then put times 3.14. In any case, don't round until you get to the very end, until you get to your answer. Or alternatively, we could write this as a mixed number. So if we do this and use our fraction to decimal button on the calculator, this should come out as 41 and 13/15 cubic inches. If you did a decimal, it's like 41.86 repeating. The 6 is technically repeating. I know it goes to a 7. That's just because the calculator is rounding that last digit off. The directions don't really tell us what to do here, so probably giving an exact answer would be the best choice. So we're going to look at the do you know how number 4. Clarissa has a decorative bulb in the shape of a sphere, has a radius of 3 inches. What is its volume? Use 3.14 for pi. So we can just start off with our formula here. So if we substitute in on this problem, pi is 3.14, radius is 3. Remember, the radius needs to be cubed. So if we cube the radius first, 3 cubed is 27. And then if you want to, you can put those over ones, multiply, and then divide it out, or you can just type it all in your calculator, whichever way you want to do that. So if you multiplied it straight across, would be 339 and 12/100 over 3, and then when you divide that out, should be 113 and 4/100 cubic inches. So if we look at number 5, a sphere has a surface area of about 803 and 8400 square centimeters. And the question, what is the volume? Use 3.14 for pi, round to the nearest whole number. I'll have to make sure to do that. So this involves two different things. One thing is surface area of a sphere. So surface area of a sphere is 4 pi r squared. And then the other thing we'll be working with the volume of a sphere. So in our first equation, we can substitute in. They told us what the surface area is. They said they want us to use 3.14 for pi. And then we'll be able to work this out. We'll be able to figure out what the radius is. Once we know the radius is, then we can figure out what our volume is. So if we multiply on the right side here, 4 times 3.14 is 12.56. At that point, to try and get the r squared by itself, they're multiplying. So we can divide by 12.56 to get that to cancel out. And when you divide that out, you should get 64. So this is looking pretty good all of a sudden. Then r is being squared, so we need to take the square root of 64. Square root of 64 is 8. We put plus or minus there, technically, is what we should do. even though we can't have a negative radius, we'll cancel out the negative. Okay, so our radius is 8. Now that we know the radius is 8, now we can figure out what our volume is. So 3.14 for pi, radius is 8. Don't forget to cube it. So 8 cubed is 512, and then if you want to, we can multiply across here. So that's 6,430 and 72 hundredths all over 3. And then we'll divide that out. One thing I almost forgot about is that we're supposed to round this then to the nearest whole number. So if you divide that out, it's 2,143.573. 3's repeating. And then at that point, we're going to take this and round this to the nearest whole number, which would be 2,144 cubic centimeters. Okay, so since our tenths spot was at least a 5, then that's why we rounded that up. We'll look at workbook page 103, number 1. We have a solid plastic sphere, radius of 8 inches. And the question, how much plastic does it take to make one sphere? Use 3.14 for pi, round to the nearest whole number. So since it's a solid sphere, it's completely solid, not just a hollow sphere. That's why we're going to do volume here rather than surface area. So we start out, we can use our volume formula, and we can substitute in. They told us that the radius was 8. We cube that is 512. And then they told us to use 3.14 for pi. You could have substituted that in earlier into the problem. So we multiply that out. We'll get 2,143.573 repeating. It did say round to the nearest whole number, so we'll make that to 2,144. Again, the little squiggly equal sign looking thing, that tells us approximately, that tells us that we rounded that answer. If we look at number 2, sphere has a diameter of 926 thousandths of an inch. And the question, what is the volume of the sphere? So again, you could start out with your formula. What we have to think about, it does tell us to use 3.14 for pi. We got to make sure we have all of our pieces here that we need. On this problem then, since we need the radius in order to find the volume, we need to take half of the diameter. So diameter here, take half of that, would be 463 thousandths. And then at that point, we can substitute that in the formula and figure out what our volume is. This time they said round to the nearest thousandth. So they're keeping things interesting, always changing it up on us. So when you work that all out, nearest thousandth should be 416 thousandths of a cubic inch.